All right, ladies and gentlemen, we're going to talk a little bit about 15.1 here. Make sure that everybody is caught up. A lot of you guys are having troubles with 15.1 and finding out what is or what isn't the properties of matter. I'm sorry, not the properties of matter, but what the types of matters there are. So the first question we always have to ask ourselves when we're talking about the types of matter is, what does it look like? Does it all look like everything is the same? So all the atoms are the same, all the elements are the same, all the compounds are the same? If that is the case, then we're talking about pure substances. If it looks like there's two or more different things in there, so it looks like you have two different types of atoms or two different types of compounds or something in there, and then we're talking about some sort of mixture. All right? So pure substances can only be elements or compounds, and we'll talk about those here in a second. Mixtures can be heterogeneous or homogeneous, and we'll talk about those later as well. But that's kind of how we just differentiate right there. Ask yourself the question, are the two items or the items that are in that group, are they all the same? If so, it's a pure substance. That means it can only be an element or a compound. If it looks like there are two or more different things inside of there, then that's going to be a mixture, which means it can only be a heterogeneous or homogeneous mixture at that point in time. So just kind of keep that in track. Let's talk a little bit about pure substances. First of all, elements are exactly what you guys think of. That's where we have one type of atom, and they're all the same. If I was to look at a picture of that, it may look like this. We'll use circles to represent. But you just have a bunch of circles that are all grouped together. This is making up an element because they're all the same type of circles, etc. from there. If we're actually talking about compounds, compounds are nothing more than when we have two or more atoms that have chemically combined together. So we have two or more atoms now. More atoms. The key here is they are chemically combined. Blake, what's up, buddy?
Are you making a video? I thought you were talking to someone.
I am making a video right now. You're on my video. Congratulations. So what that looks like, if we're to draw a picture of that is, so now let's add in, I've got my circle, I got my square, and now I got my circle. I've got my circle, and I got my square. Notice how I have two or more atoms that are combined, and notice that they are touching right here in the middle. So they're touching right there in the middle, which means they're chemically combined. They have a new set of properties. They have a new set of chemical and physical properties from there. So elements, one type of atom. They're loosely grouped together. They're all the same type. They're not touching, etc. from there. Compounds. They're two or more atoms that are chemically combined together. The key is you have different things that are actually touching each other and so on from there. All right, so let's talk about mixtures now. What do we got going on there? Again, we said there are two different types of mixtures. Heterogeneous. Heterogeneous is going to be pretty simple. We can easily see the parts, and we can easily separate the parts. What does this mean? This actually means, take a look at pepperoni pizza. Okay? So my example for this is pepperoni pizza. You can use sausage if you prefer sausage. You can use mushroom, whatever you want. It doesn't really matter. But if I asked you to pick off the pepperonis on a pepperoni pizza, you could easily do that. If I asked you to eat the pepperonis, it would still taste like pepperoni. It wouldn't taste any different because they retain their individual properties. Salad, another example of a heterogeneous mixture. We could pull the lettuce out. You could pull the cheese or whatever else out. And again, the cheese, the lettuce, the bacon bits, everything else have their own individual properties. So these are two or more things that are combined together. We can easily see it. We can easily separate it. And they can actually retain their individual properties. Lucky Charms, M&Ms, any of those things are things that we could pull out the red, the blue. We could pull out the marshmallows or the cereal. All of those would be considered our heterogeneous mixtures. All right, so let's take a look at homogeneous or homogeneous mixtures. The difference here is you have two or more things that are not easily seen, but they're actually blended evenly, meaning we can't see the different parts. Coca-Cola, Windex, Kool-Aid, tea, all of those would be examples of a homogeneous or homogeneous mixture. They're blended evenly, look like one thing, but yet we know that they aren't because the individual properties are still there. So we blend it evenly, we cannot see the different parts. It looks like it's all one thing, but we know that there are actually multiple things in there. Coca-Cola, we know that is in there. What I say, Kool-Aid is another great example of a homogeneous mixture. If I make my Kool-Aid and I don't think that there is enough sugar in it, I'm going to add more sugar in it, and then I can start to taste that it's becoming sweeter. So that's the way we know that it is a homogeneous mixture, is because the sugar in there is blended so evenly we don't see the sugar when we hold up the glass of Kool-Aid, but we know it's in there just by its taste alone. If I asked you to open up a Coca-Cola, you come back 2 weeks later, you go to drink it, it's going to taste flat. It's going to taste flat because the Coca-Cola has lost all of its carbonation or a carbonated gas. We don't see the carbonation in the Coke. It looks like it's all one brown liquid, but it's actually in there, and you like when it's in there because it's all fizzy and it tastes well. So again, homogeneous mixture, it's blended evenly. It looks like one thing, so we can't see the parts, but each part has its own individual property. Sorry about that. Alright, so if we were going to mix together or take a look at what it actually looks like with heterogeneous and homogeneous mixtures. So let's go back to our particulate diagram. We've got heterogeneous. Let's use our circles. We've got blue circles. The blue circles are all the same. That's great. And we've got some yellow squares all over the place. That's great. The key to making this a heterogeneous mixture is we can actually see the individual parts, and there's actually separation between those parts. That would be easily separated. If we were taking a look at what a homogeneous mixture would be, we're going to use the same kind of stuff here, but what you'll notice is that the homogeneous mixture, everything is kind of just scattered about. There's no organization, there's no pattern there. We have two or more different things. The two or more different things have their own individual properties, but there's no separation between the right side, left side, top side, or bottom side from there. So this is a difference between heterogeneous, homogeneous mixtures. Again, if we take a look, homogeneous, blended evenly, looks like one thing. We can't see the parts, but we know the parts are there because if you take one out, you can taste the difference or maybe feel the difference, etc. Heterogeneous mixtures are easily see the parts. They're easily separated. They have their individual properties. Pepperoni pizza, salad, etc. are examples for that one. And then pure substances are either elements or compounds. Elements have only one type of atom that are scattered around, unattached. Compounds have two or more atoms that are chemically combined. You can see that by them actually touching. And when they combine, they have their own set of physical properties, chemical properties, etc. from there. Going all the way back to the very, very, very beginning, the first question you always have to ask, is everything the same? If everything is the same, the only thing it can be is a pure substance. If you have two or more things involved in it, it can only be a mixture, which means it can only be heterogeneous or homogeneous. I hope this helps, guys. I'm going to upload this as soon